Right, polynomials. So a polynomial is a function that is in this form. It's a lot there. Basically what it means is we have exponents that are non-negative integers, right? So anything 0, 1, 2, 3, 4, 5, 6, 7, right? And any of the other natural numbers there. So integers that are not negative. So if you look at the first one here, right, this is really 4 times x to the 0 power. But since x to the 0 power is just equal to 1, right, writing it as equals 4 is the same as writing it as 4 x to the 0 power. It's the same thing. Okay. And over here we have x to the 1, x to the 2, x to the 3, to the 4, right? There's a 2 there, a 2 there. So the exponents are non-negative. They're positive or they're 0. Okay, non-negative integers. That's basically what a polynomial is going to be. All right, so the two most important things are the number in front of the largest exponent is called the leading coefficient. And it's down here too, coefficient. The leading coefficient, okay? And that number is the number in front of the largest exponent. And the largest exponent is going to be called the degree. So if you want to look down here at some examples, okay. Again, y equals 4, f of x equals 4 is really 4 to the x or times x to the 0 power. So this is a 0 degree polynomial because the largest exponent is 0. And the leading coefficient, the coefficient in front of x to the 0 is going to be 4. Right, for the next one, the largest exponent is x to the first, right? There's really a 1 here, even though we don't write it. And the leading coefficient in front of x to the first is negative 5. So the largest exponent here is 2. So that's going to be x squared. I'm sorry, x squared is the largest. So 2 is the largest exponent. So it's going to be a second degree polynomial, which is also called a quadratic. We have a third degree polynomial here. We have a fourth degree polynomial. And we have a fifth degree polynomial. It doesn't matter what order you write them in. The largest exponent is going to be the degree of your polynomial. Okay, and then whatever coefficient is in front of that term, that's going to be your leading coefficient. So 12, -1, -3, and 9. Your leading coefficient is the number in front of the largest exponent of your polynomial. Okay. Parent functions. So a constant function might be something like y equals c. Right, it's just going to be a line. Okay. Linear, so that's an x to the 0 power, right? X to the 0 power. Over here, we're going to have x to the first power. That's going to be a line, right? Y equals mx plus b. It's going to look something like this, right? You're going to have a line. Okay. X squared is called a quadratic, right? So it might be something that's like y equals x squared, right? So it's going to look like this, right? Quadratic. Cubic, y equals x to the third. It's going to look something like this, right? Third degree polynomial. Okay. And then quartic and quintic. These are just wider versions. So y equals x to the fourth. So it's actually thinner, kind of more coming down than your x squared. And then y equals x to the fifth is going to look very similar. Again, it's going to be kind of compressed version of x to the third. Okay, so those are kind of your base functions there. All right, so I'm going to fill in actually the box at the bottom first before we answer 1 through 6. Okay, so we want to fill in our sketches here to help us remember end and behavior. So I'm going to put some x and y intercepts here. X and y intercepts. And all of these. Okay. So if it's the leading coefficient is positive, right? And the degree is even. So x squared or x to the fourth or x to the sixth, right, is our leading degree, our largest exponent. It's going to look something like this. It's going to come down, it's going to do stuff, and then it's going to come up. So it's going to be positive as you go left, and as you go right, it's going to go up towards infinity. Okay. So let me draw that first one up here. Right. So that is, well, we can redraw them at the end there. All right. Even and then negative is going to look something like this. It's going to go down. Okay. Odd and positive, so something like x to the third is going to look something like this. Okay. And then odd and negative, that's going to be flipped, so it's going to look something like this. Right. I mean, it's going to do stuff in the middle, right? So it might do a bunch of different things in the middle and then go down. Oh, I'm sorry, that's odd and positive is going to do this, right? Something like this. And then odd and negative, right? So that's what your 4 should look like. Okay, whenever its degree is odd and the leading coefficient is positive, right? This is the general idea of what your graph's going to look like. All right, let's look at some examples now. So 1 through 6 here. Okay, so this is even and then positive, right? So the degree is even and the leading coefficient is positive. So again, that graph's going to look something like this. Okay, which means as you go to the right, the f of x is going to go up towards positive infinity. Okay, and as you go to the left, as you go towards negative infinity to the left, it's also going to go up, right? So as we went right, it went up. And as we go left, it goes up, right, to positive infinity. Over here, we have even and negative. So if it's even and negative, even and negative, right, it's going to look something like this. So as we go to the right, we're going down towards negative infinity. And as we go to the left, right, we're going down towards negative infinity. It's going down and down as you go left and right. Okay, this one we have odd and positive. Right, so it's going to look something like this. So as we go to the right, it's going to go up towards infinity. Right, as we go left, it's going to go down towards negative infinity. Right, as you go right, it goes up. As you go left, it goes down. Okay, this one's going to be odd and negative. So it's going to look something like this. It's going to come down and look like this. Okay, so as you go to the right, you're going to go down to infinity. So that's going to be negative infinity. And as you go left towards negative infinity, it's going to go up towards positive infinity. Right. Here you got even, and you have negative. So if you have even and negative, right, it's going to look something like this, and then go down. So as you go right, you're going down. As you go left, you're going down. Okay, and then again, this is positive and odd. So it's going to look like this. This means as you go to the right, you're going up. And as you go to the left, you're going down. Okay. So then 7 and 8 here, right? So 7, right? This is going to look like this one right here, right? So it's even degree, right? Even degree. And then the sign of the leading coefficient is going to be negative, right? So then negative, even and negative. This one is going to be odd and positive, right? So this is going to have an odd degree and a positive leading coefficient. It's going to be odd and positive. Right, so next up for graphing is turning points, okay? So whenever a turning point is going to be when a polynomial switches direction. So if the turning point is higher than any nearby point, right? So if it's higher than any nearby point like this, we're going to call it a relative maximum. Maximum. If the turning point is lower than any nearby point, we're going to call it a relative minimum. Minimum, right? So we have a relative maximum up here and then a relative minimum down here. Okay, those maximums and minimums are called turning points. Those are the turning points. Okay, where we go from increasing to decreasing or decreasing to increasing. All right, so how do we find those turning points if we have a polynomial? Well, we look for the relative minimums and relative maximums. So if I go to my graphing calculator, okay, if I go to my graphing calculator, I'm going to put in, I'm going to add a graph. Actually, let me do new document. Okay, add a graph. Okay, I'm going to put in x to the third power. All right, pull minus 6x squared plus 7x plus 2. And I'm going to hit enter. All right, so there's my graph. Okay, if I want to find my relative minimums and maximums, okay, what I'm going to do is I'm going to menu, analyze graph, maximum, right? And I'm going to click to the left, click to the right. There's my maximum, 0.79. Let me round it to 0.71, comma, 4.3. Okay, my relative minimum. If I want the minimum, I need to go to menu, analyze graph, minimum, click to the left, click to the right. There's my minimum at 3.29, comma, negative 4.3. Okay, so there's how you find your relative mins and maxes on the calculator once you've graphed your polynomial. Okay, and then our intervals, increasing and decreasing. So if we look at increasing intervals, we notice on our graph, we're going to start all the way on the left, right? So we're going to start at negative infinity. Okay, we start to the left, we start increasing, right? We're going up. As we move to the right, we're going up, 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 until we get to our relative maximum of 0.71. Okay. So we're increasing there. Okay, then our graph begins to decrease. So we have a turning point, right? A turning point. It's going from increasing to decreasing. So 0.71 is our first turning point. So now we're decreasing, 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 going down until we reach 3.29. So we're going down from 0.71 until we reach 3.29. Okay. And then at 3.29, we begin to increase again. So then we go up, 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 all the way from 3.29, all the way to the right, all the way to positive infinity, right? As farther right you go, the higher up it goes. Okay, so those are my positive, right? The red is where it's increasing from left to right. The green is when you move left to right. That's where it's decreasing. That's your decreasing interval. Right? Okay, we got 4 examples we're going to do here. I don't know if we're going to do them all. Let's do a few of them though. Okay, and then there's some practice. Okay, graph each polynomial using a table, then give its domain, range, turning points, and end behavior. So if we're going to strictly use a table in the future, where you come up and make your own table, that's fine. But for now, let's do this where we graph the function. So I'm going to put this in my calculator. Move my graph back up here. So we have negative x to the third plus. So I'm going to get tab and go back to my original. Delete all this. I have negative x to the third plus 3x squared. X squared. Okay, I'm going to hit enter. Okay, and then from there, we're going to look at domain and range. So domain is all the possible x values. So it looks like we can keep going to the left, right? And we can keep going to the right. So our domain is going to be from negative infinity to positive infinity. The range are all the possible y values or f of x values. So we can go all the way down and we can go all the way up. So it looks like our range is going to be from negative infinity to positive infinity. Okay, we can go all the way left, all the way right, all the way up, all the way down. All right, relative maximum and relative minimum. So our relative maximum, we need to analyze graph. Click maximum to the right and to the left. It looks like it's going to be, not really sure what this other one is here. Looks like it's going to be 2, 4. Okay, is our relative maximum here, 2, 4. Perfect. Okay, and then we can find our relative minimum menu, analyze graph, minimum. Click to the left, click to the right, 0, 0. 0, 0. Okay, end behavior. So as we go to the right, our function is going down. So as x goes to infinity, y or f of x goes to negative infinity. As x goes to negative infinity, so as we go to the left, our y value is going up towards positive infinity. Okay. And then our increasing, decreasing intervals. So we start off in this graph by decreasing, right? We're going down to start. So we're going down, 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 down until we reach 0. So we're decreasing from negative infinity, right, all the way to the left. As you read it left to right, starting at negative infinity, we're going to move to the right until we hit 0. And then at 0, we begin increasing again. Or we begin to increasing for the first time. So we increase, 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 increase until we reach 2. Okay. And then we decrease again after that. So then we start going down from 2 all the way to infinity. Okay, if we were going to use the table for this, we would hit Control T or Menu Table. Okay, and as you look at the table, you'd be able to determine if the graph is going to be increasing or decreasing. So if we look at this table, the way we would do this is we would look, okay, it's decreasing, right? It's getting smaller and, whoops, I went too fast. Okay, right? See, these numbers are getting smaller and smaller as we move from left to right. Okay, smaller and smaller until we hit 0. And then you can see at 0, right? It's right? This is decreasing, right? It's going down, decreasing, going down, decreasing, going down. But all of a sudden at 0, we switched from increasing to decreasing, right? So that's how you would figure out that this is a turning point. We notice on our table, it's going from decreasing to increasing. We have a turning point. Okay. So if you make your own table, that's how we would do this. Our other turning point is going to be at 2, right? So again, we notice from 0 to 2, that's increasing, increasing. Okay, but all of a sudden we notice it decreases here. So we have a turning point, right? So our turning point was 2, 4, right? Our 2 turning points were 0 and 2. Those are our 2 turning points. All right, let's do, I guess we can do one more example on here. Okay, let's do one more. Let's get rid of the table. Okay, tab. Let's go up here and change this. Okay, so our function we're going to do this time is going to be x to the fourth. X to the fourth plus x to the third minus 4x squared plus 5. I'm going to hit enter. Okay, there's my function. Okay, I'm going to zoom out a little so I can make sure I see it good. So I'm going to zoom out a little, which is great. Okay, I'm going to do menu. Actually, I'm going to zoom back in because it looks like I see it all. Okay, good. Can we get rid of these somehow? Delete. Well, that's fine. Let's put it back in. X to the fourth plus x to the third minus 4x squared plus 5. Enter. Okay. And then let me zoom out a little. There we go. Awesome. Okay. So let's look at the questions they're asking us here. Domain, all the way to the left, all the way to the right. So that's negative, right? You keep going all the way left, all the way right. So negative infinity to positive infinity. Okay, range. It goes all the way up, but it stops right here. Okay, right here. So we have a minimum here. So we need to find that minimum. All right, so let's look at this. We're going to go to menu, analyze graph, minimum, right there, negative 1.84. And the y value is negative 3.31. So the range is the only time you use the y value. So it's going to be negative 3.31, the lowest y value, and then it's going to go all the way up to positive infinity. Okay. Relative minimums, relative maximums. So I have a minimum there. I have some more though. I need to find them. So menu, analyze graph. I have a maximum right here at 0.5. Menu, analyze graph, minimum, right? 1.09. So my relative maximum is going to be 0.5. My relative minimums are going to be negative 1.84. Comma negative 3.31. Okay, and then 1.09, comma 2.95. I didn't write that one very well. 2.95. Okay, and behavior. As we go to the right, this graph is going up towards positive infinity. Okay, as we go to the left, it's going up towards positive infinity, right? And that makes sense because it was even and positive. So, yep. Okay, and then our increasing intervals and decreasing intervals. So we're decreasing here. Okay, we're decreasing, right? We're going down, 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 down until we reach negative 1.84. Okay, so we're decreasing from negative infinity all the way until we reach negative 1.84. We're going down. Okay, and then we have a turning point. So now we start going up, 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 up. So we go up from negative 1.84 until we reach 0. Okay, and now we're going down. We're going down, down, down from 0 until we reach 1.09. Okay, and then we're going up again from 1.09 until infinity, right? Until we reach infinity. Okay, so there you go.